doing any mathematics in the last year before university, you're probably going to do an exam at the end of the year. And that sort of covers everything you learn throughout the year. So where I did it, I did mathematical methods and specialist mathematics, which are things in the Australian curriculum, but I'm pretty sure in the US it would equate to calculus A, B, B, C, and maybe physics C, from what I've heard. So I'm going to tell you about how you can write your cheat sheet. So the first one we're going to look at is mathematical methods, obviously. People will probably consider that the easier one, and that's because you're probably going to be able to see 5 distinct topics: differentiation, integration, binomials, discrete random variables, and continuous random variables. And that is all the units that you study across the entire year. So what are you likely to actually see in the exam? Well, you're probably going to see some derivatives of things that aren't polynomials. So you're not going to see derivative of x cubed, you might see a derivative of sine of x. And so it's good to just write down all of the strange derivatives, so the transcendentals if you want to be fancy. So the trigonometries, the natural log, the derivative is 1 over x, and the derivative of e to the x, which is just e to the x. So it's pretty stock standard. And then it's also good to have the 3 rules, the product rule, chain rule, and quotient rule. And obviously with these derivatives of trigonometry and stuff that's just sine of x, you can extrapolate that to sine of f of x, so f of x being anything within sine of x, and just use the chain rule to expand that, and all the derivatives are solved. Same with integrals, you can just do the opposite for the integrals, and it's good to write some of the ones that you might encounter commonly. Pretty alright stuff, I think. Then for me, when I did the exam, there seemed to be a lot of visuals, so there's a lot of graphs, and you had to turn them into sign diagrams like I've got here, or write what they might look like. And so it's good that I've put in a concave up and a concave down quadratic, as well as 2 cubics, just pretend that they're cubics. And I've written the sign diagram that corresponds to the function itself, the derivative, and the double derivative of that function. And that's for all 3 of them, assuming that the point we're looking at is either the point of inflection or the 0 for those appropriate functions. And that's good because you'll definitely see something like that. There's a lot of what does the double derivative look like, or the single derivative looks like this, what does the initial function look like, and those kind of ones. And if there's any other graphs you want to visualize, for example, there was a question that asked what does the graph of hyperbolic cosine look like, and obviously it just looks like a bit of a flattened kind of quadratic in locally, obviously. But it's good to just write down any other graphs that you want to have a look at, and that's pretty much all you're going to find with calculus. I said you were allowed to have 4 sheets, but honestly I couldn't really think of anything else to put after I sort of went on the second sheet, because the only other stuff you can look at is statistics and probability. Binomials, DRV and CRV, they all sort of fall under the same umbrella of statistics and probability. And so obviously with probability, the main thing is to think, okay, I've got like a chance for something to happen, and I've got all these possibilities, so what's the probability, how can I graph that, etc. So the X always represents the event, a big capital X this time. E of X, if you see that, then that means the expected value, which is the same as the mean, same as the average. Tensor from the future here. I think I got a little bit carried away and started trying to explain all the things that were on the cheat sheet, but I remembered that this wasn't a video meant to explain what these concepts and topics are. This is a video explaining what you're going to see. So obviously on this second page you're probably going to see some stuff to do with standard deviation. You're just going to know that almost always is denoted sigma. You're going to see stuff to do with confidence, and it's almost always denoted, with like an X with a line over the top of it. And you're going to see expected value, which is E of big X. And so that's what the things written on here are about. And obviously where there's square brackets, put in the real thing, because I don't want you to write in square brackets confidence equation on your cheat sheet, because I don't think that'd be very helpful. These are just sort of plug and play equations. If you've got 2 of the values that you know and you want to find the third one, then you just put it in and see what you get. And honestly, there's not much else you need. You're going to get handed another sheet that has some pre-written equations that might be useful, might not be useful. and everything else is pretty conceptual. If you know how a normal distribution looks, you know how statistics work, and also you can solve a derivative given sort of some function, you'll be pretty set. The methods exam was pretty simple. If you want to get a nice visual of the normal distribution, that might be helpful as well, which is why there's a little circle there with a graphic. Obviously don't get one that sucks like the one I put here, but I couldn't find a good one, so I just sort of that just represents you put something there.